happens. But when we look into this Six Sigma part of it, we try to do a statistical process control where we monitor, improve, and control a process using statistical tools. So a control chart becomes a part of statistical process control. It becomes a control mechanism how we can sustain the improvement over a period of time. So a control charts are used for controlling or sustaining the improvement of the process. So a graph is plotted over a time order to see the changes over the time and see that process variation is consistent or unpredictable. A special cause variation happens when there is a can be easily identified by a control chart. So every control chart will have a central line, which is a mean value, upper control limit, and a lower control limit values are there. So when we see the control charts, so this is the mean values are there, the upper control limits and the lower control limits are automatically calculated using certain equations. And where we can see the data is seen within the upper control limit and lower control limit without any uh, trends or patterns. We say there are random variations in this process. If any point goes beyond the lower control limit or the upper control limit, we say they are a non-random variation region. There is some special causes for the data to be seen in this region, or if any run or trend patterns are seen, it can be easily identified by a control chart. So different control charts are there, just for your understanding. So variable control charts and attribute control charts are there. Based on what are we controlling or what metric are we measuring from the process. Variable control charts based upon how much number of samples we are collecting at a time. If we are every time we are taking only one sample, then we use IMR chart. If the subgroup size, the number of samples we collect at a time, the subgroup size is more than 1, but less than or equal to 8, we use X bar R chart. IMR is individual and moving range. X bar is mean and range. Subgroup size is more than 8 when we use X bar and S chart, that is mean and standard deviation. Similarly, attribute control charts are classified. What are we classifying or what are we using in our control charts? So the count of defectives are used when we are categorizing the outputs into pass, fail, or yes or a no, or good or bad. We are classifying those outcome of the process into defectives. If the sample size is constant every time, then we use NP chart, we call as number of defective parts chart. If the defectives are not constant, we use a P chart or the proportion chart. If we are counting the defects on the process, if the subgroup size is constant and we use C chart when the defects are a constant. If this U chart is used when the subgroup size is not constant. So this is certain rules which has been established by Walter Shewhart when he developed the control chart, so special cause variations. So this is where when we look into this Western-centric rule, where the company where the Walter Shewhart was working, so there's 7 rules were developed, and it said that if any point which is going beyond the control limits, then it is upper control limit and lower control limit is +3 standard deviation and -1 standard deviation from the mean, then it is called as a special cause variations. If 7 consecutive points are on the same side of the center line, it is similar to that of the what we're seeing, the clustering of the data, which we see in the run chart. 7 consecutive points increasing or decreasing, we have seen that as the trend patterns in run chart. In control chart also it has been seen. So 14 consecutive alternating up and down, we say it is a trend pattern again. So the oscillations that we are seeing. So this is the Western electric rule has been given. So similarly, if any point 2 out of 3 consecutive points are beyond zone A, which is zone A or beyond, is below -2 sigma from the mean or +2 sigma from the mean. Out of 3 consecutive points, 2 points are in zone A, then it is a special cause variation. Out of 5 consecutive points, 4 points are in less than 1 sigma level or between -1 sigma, 2 sigma, or 3 sigma. or +1, +2, and +3. We see the B zone and the A zone. Then we say there is a special cause variations. 14 consecutive points in C zone, it is a special cause variations in the process. So this is the different rules are being given. The rule 1, we say that is any going beyond the out rule. So when we say it is a special cause variations, clustering of the data, when we say the rule 2, trend is a rule 3 that we are seeing in the data. Rule 4 is 14 consecutive points alternating up and down. So each rule we can see out of 3 consecutive points, 2 consecutive points in A zone. Out of 5 consecutive points, 4 points are in zone C, and 14 consecutive points in C zone, or within +1 and -1 sigma from the mean. So if any rule is present, then this red squares indicate the presence of special cause variations. So this is how the special cause variations are identified in Minitab using the software. We can see red squares indicate the special cause variations. Similarly, this is a variable chart, IMR chart, individual and moving range chart has been seen. Similarly, for an attribute control chart, a P chart has been shown. A special cause, when it is there, red squares indicate the presence of special cause variations. Lastly, when we look at the control plans, so control plans help us to understand so how we can enforce the that the data collection will happen and the monitoring happens on a regular period. So that is where the control plan help us to ensure the regular process audits are done and the process is sustaining the improvement so that there is no rework happening in the process for sustaining the improvement. So when we create a control plan, we say what need to be monitored, who is going to keep the process functioning properly, and how do they going to monitor it, and where the monitoring is conducted, where will the plan reside, and what will be done if undesirable conditions are present. So based on these questions that we get an answer, we create a control plan with the control plan template. For example, the process is order fulfillment process. Order fulfillment time is a critical Y that we are looking into. The specification says it has to be between 30 days to 60 days. From the software, it has to be collected 5 samples per week. So how the project, once we are completing the project, how the sustainment of the improvement should happen, how the monitoring of the process should happen, we are giving it in a control plan. So we are saying 5 samples per week to be collected weekly by the quality analyst and should use a X bar R chart. And when the order fulfillment time is taken more than 45 minutes and a corrective action need to be implemented in the process. So this is how a control plan help us do. So when we give it to a process owner, the head of the department, we close the project and say that this is how the sustainment need to be happening in the process. So that is the control plan. So control plan is giving the how a process need to be monitored over a period of time.